Let's now take a look at CMS and CMT swaps. A CMS swap is a constant maturity swap. So basically, you have a swap where the floating side is based on the swap rate of a swap with a constant term. For example, at every reset, your payment is determined by a 5-year swap. So if reset time is 1, the first reset, you take the 5-year swap, the swap rate for a 5-year swap at that particular time. Then in the next reset, you will also take another the swap rate of another 5-year swap. So every time at the reset time, you'll always be taking the swap rate of the 5-year swap at that point in time. So the reference swap is always a 5-year swap in this example, and that swap changes from reset time to a reset time. Every time you take a different swap. The constant maturity treasury swap, which is CMT, is has a similar concept where every time when you do at the reset time, you take a yield of a constant maturity of treasury bond. So for example, in this case, at the first reset date, you take the yield of a 10-year treasury swap, treasury bond, and the next reset time, you'll also take the yield of a 10-year treasury bond. The two bonds are different at the different reset time. They are both the current 10-year treasury bond. But since let's say if you take the 10-year treasury as the reference one, then if the first reset time is 1 year from now, and the second reset time is 2 years from now, 1 year from now, you'll be taking a 10-year treasury bond there. And 2 years from now, the original treasury bond will become, instead of a 10-year, become a 9-year. So you cannot use that. So you have to select a new bond that has a 10-year maturity at 2 years from today. So CMS and CMT, you will see that they actually will require both a timing adjustment and a convexity adjustment. So in fact, you will do a convexity adjustment first, then you will do a timing adjustment. Now the reason for that is you need to, your reference is always has a constant maturity. Now, so what is that basically? Well, take the CMS, for example. You need a swap rate. The swap rate, it has a constant swap tenor. So say T is your reset time. Okay, so you need a constant tenor of a swap rate. But you get paid at T plus 1. So what do you need? So then if you set it up according to the equivalent martingale approach, you would have, the price of that, or the value must be a discounted value of the expected payoff. The expected payoff is really this notional times this swap rate, right? The notional is constant, so you put it out. Then since the payment occurs at T plus 1, the numerator that you select should be the zero coupon bond from today to Ti plus 1. So you would need an expectation that is consistent with this zero coupon bond here, which is from current time to Ti plus 1. Now, you don't really have that. So you don't really have that as an easily observable market variable. What you really can have is actually, you actually have this. Instead of ETI plus 1 of this thing here, you have ETI, which is, what is this? This thing is basically the forward price of a coupon bond. So you do have the forward price of coupon bond. Well, actually, you get the yield, from the forward price of the coupon bond, you get the implied yield, and that yield is this thing here. So when you take the yield, you have to do a convexity adjustment to get this. Okay, so let me repeat again. So you have the forward price of the coupon bond right now, and the forward term is so if this is a 5-year swap we're looking at, you're looking at a 5-year coupon bond. So if the first reset time is 1 year from today, it's actually a 6-year bond right now, but you're looking at its forward price 1 year from today. At 1 year from today, that particular bond is a 5-year bond now. 1 year from today, so you know the forward price of this bond 1 year from today that has a remaining maturity of 5 years. So out of that bond, you can calculate from the forward price, you can calculate the yield, the implied yield on the forward price. But you need to do a convexity adjustment to get this thing here. Okay. Now, this, however, isn't what you need. You need ETI plus 1 to get this is an expected value based on a zero coupon bond that's from 0 to TI. So here you have used, because your payment is on TI plus 1, so you use a different zero coupon bond as a numeraire. So you have to change the numeraire from an expectation using PITI to a numeraire that is PITI plus 1. So you accomplish that by doing a timing adjustment. So let's see how we're going to do that. So basically, you first of all use they take the corresponding take the corresponding coupon bond there. Say the first reset time is 1 year from today, then you would take the forward price of a bond that 1 year from today has a 5-year term, and you will take the yield, and so you would then use the adjustment. So this will be the yield of that bond there, and then you will go through this convexity adjustment as we have seen earlier. So take the second partial and the first partial to get the adjustment. Now, once you have done this adjustment, you will get this expression here. Now, don't be confused that we do have at the current time, we do have a forward swap rate for the reset time at say 1 year from today of say a 5-year swap. Okay, so you do have forward swap rate, but that's not what you can use. So if you have reviewed your the earlier lectures, you will see that the forward swap rate is actually this, where the it's an excitation under a new under a numeraire that is actually an annuity. Here we need an excitation with a zero coupon bond that matures at Ti as a numeraire. So they have two different numeraires. So you can't really use it, or at least it's not that easy to switch the numeraire asset from this to this. It's much easier to switch numeraire asset between two different zero coupon bonds. You just need to change the drift a little bit here, okay? Because you have the so it's not advisable to actually try to take the floor swap rate and try to use it. So instead, take the floor price of a coupon bond and do the convexity adjustment. Now, once you have got to this stage, and you then need to use, you have this, but still this is not what you need. So you need numeraire based on a different one. So, but you know how to do that adjustment. You just do a timing adjustment here based on the formula we have seen earlier. Then once you have that, you're all set. So basically the value that you required in the calculation here. So once you have obtained that value, just have that value multiplied by the notional and discounted, then you get your value here. So to get here, you get the yield off from the zero coupon bond. Sorry, the yield from the coupon bond of the correct maturity, do the convexity adjustment, and do the timing adjustment. Okay, so what are those things that we use here? Basically, yi are the forward yield, as we discussed, of the coupon bond. Fi is the forward rate at Ti. And these are the first and second partial derivatives of the coupon bond. And this sigma here is the implied vol of the swaption. And this sigma f is the implied vol of the caplet. So you need sigma yi in the second adjustment here, and sigma f is here, right? So sigma yi and sigma f. And rho is a correlation between these two that allows you to do the timing adjustment. Okay, so you actually need to do this adjustment for each of the payments. Okay, so here for each of that payment at the reset, you have to go through this, and then you add them together. They give you the value for the for one side of the payment of the swap. So this gives you the floating side for one payment. Then you add the floating side of all the other payments together. You give you the entire value of the floating side. Then you use it minus the value of the fixed side will give you the value of the swap. So the key here is really the adjustment of the two adjustments that we need to determine the actual floating site rate that we can use in the valuation here. So, I suggest you to review under equivalent marking measures how we set them up and what, in this case, what is a swap rate, the solved swap rate is, under which martingale, excitation under what numeraire. And also review convexity adjustment we have. And from then, we can calculate the prices of the CMS. And CMT is calculated in a very similar fashion. Now, next, we're going to talk about differential swaps.